naming ionic compounds can be one of the hardest parts of grade 9 science. So I wanted to just go over one more time another way of doing this and hope that it makes it a little bit more clear for any of you who are still having trouble. First and foremost, ionic compounds are made from bonds that are formed when cations, the positives, join with anions, the negatives, to make a neutral molecule. So the whole point that we're trying to do is to make our molecule neutral. So to do that, if you start out with any element. So if we start out with, for example, that's interesting. Hang on a second here. If we start out with Na, 1 plus, and then we had Cl, 1 minus, we could take this molecule and say, okay, we've got 1 plus, and we have 1 minus. So that means that these two particles, when you add them together, will make a neutral particle, meaning we will get NaCl. And because we don't write the ones when we are doing ionic compounds, you're just going to write NaCl, put your little solid beside it, and you're done. Now, for this one where the charges match, it's a lot easier. But when we've got one where they don't match, this is where we have to start thinking a little bit more. So let's keep our chlorine, but now let's do calcium, which is a 2 plus, and Cl, 1 minus. So if you look at this, you have 2 positives here and only 1 negative here. So if you want to have a neutral particle, does it make sense that you would then need more negatives to balance out our positive? So I'm hoping in your brain you're thinking, well, yes, of course we do, Miss Young. So here we're going to take another one of these chlorines, and now I have 2 minus as our total and 2 plus as our total. So when we add 2 plus to 2 minus, we get a neutral compound. That means our compound will look like CaCl2. Now this 2 right here means that we needed 2 of these chloride anions. We needed 2 of them to balance the charge on the calcium. So we're using this 2 down here to balance the charge. So when I was showing you the crossover method before, that's just a shortcut in how this whole process works. So when you take your crossover method, you have Ca 2 plus, Cl 1 minus. Sorry, my plus and minus didn't show up very good there. Cross these down. They lose the positives and negatives. You get Ca1, Cl2. We don't write the ones in chemistry, so you're left again with CaCl2. So you're actually using that crossover method to balance these charges. So I'm going to do another couple just to make sure this makes sense to you. I just have to go back here and erase all of this so that I can do another one. Okay, so let's try another one. Let's do francium, which is 1 plus, and let's do nitride, which is a 3 minus. So here we have more negative or more anion than we do our cation, which is our positive. So we're going to have to add another cation and another cation so that I can get my total charge to 3 positive to balance out my 3 negative. So because I took 3 franciums, I would put Fr3N, and I don't write the 1 even though there is one of them, and then I'd write my solid. So here, francium 3 nitride. When you're looking at the periodic table, my favorite periodic table online that I've been showing you again and again and again, it's a great periodic table, but it doesn't give you the charges in any way that's easy to find. So go back to D2L and take the JPEG that I put of the periodic table. That one has the charges and the names written out for you. For all of the ions on the periodic table, you do not need to memorize them. You just need to know where to find them. Okay, let's try another one here. Aluminum Al3 plus O2 minus. So we could cross our numbers down and we'd get it right. But how we do that and what it means is when you've got a 3 plus over here, you can only add whole molecules. You can't add a half. So here you need another oxygen because you have less than 3. But now I have 4 negatives and 3 positives. So I'm going to have to add another aluminum. And then I'm going to have to add another oxygen because I still didn't have enough. So now here I'm going to have 6 positive, and over here I have 6 negative. So if I add these together, I can get a neutral particle. That neutral particle will have 2 aluminums and 3 oxides. So when you do that crossover method, Al3 plus O2 minus, you're crossing down these charges and eliminating this step. So it gives you the same information, it does the same thing, it's just trying to make it a little bit easier. Let me show you the exceptions. So if you use this crossover method, you will get 80% of all the ones in grade 9, maybe closer to 90% of all of the compounds correct just using that. The exceptions are going to be these ones. So for example, if you had Ca2 plus O2 minus, you already have the same charge on the positive as you do on the negative. So when you add these together, you already get a neutral compound. That means you only really need one of each. So your total compound would be CaO. It looks terrible. Let me fix my O. Now, if you use the crossover method on this, Ca2 plus O2 minus, and you cross it down, you're going to get Ca2O2. But because both of these 2's are divisible by the number 2, you need to divide them by 2 to get back to your CaO solid. This is the only tricky part. If you, in grade 9, left it at Ca2O2, I would say to you, you're almost there. You have one more little step. And this could still give you like a fairly good mark overall on if you got everything else right, because it's one small mistake. In grade 10, this is going to be a much bigger deal because you should have already learned it by then. They will also go over this as well. So the only time that this doesn't work is when those charges are already balanced when you start, or you need to have less. So for the second example would be like if you had lead, so Pb4 plus and O2 minus. Again, here, this one's just double of that. So if you cross them down, it would say that you needed 4 oxygens. But just looking at these two, to make a neutral compound, you actually only need 2. So your compound here would be PbO2. All right. I'm going to erase these, and I'm just going to do a couple with the crossover method to make sure you guys know what's happening. And hopefully it makes sense. So let's do lithium and nitride. So if we cross these down, lithium, 3, nitrogen, you would write a 1, except that we never write 1s, and you put your solid, because that's important. You could do silver, Ag1+, and you could do phosphide, 3-. We'll cross these down, becomes silver, 3, phosphide, solid. We could have magnesium, and we could have chlorine or chloride. We'll cross these down, Mg1 here, Cl2, solid. And one last one, let's do beryllium and sulfide. So here's the tricky one where they already match, so then you just put them together. BES, solid. Okay, I really hope that helped you guys. Let me know if you need more help. I'm happy to meet up with you.